Forces on an incline involving friction. Now, these style questions are probably some of the most difficult style questions you'll come across in a Mechanics 1 paper. This example we're going to look at here is quite an easy example to set us up with the basic skills required to answer questions involving some kind of object on an incline. You could also be asked to look at forces around a pulley system, which we'll look at on a later video. Now, the biggest thing you must do with any forces question is to make sure you highlight all the forces on the diagram and in which direction they will affect the object looking at. So, let's have a look at this question and then highlight the key points to enable us to draw a diagram. It says a box of mass 5 kilograms is held at rest on a slope raised at an angle of 30 degrees. The box is released and begins to slide down the slope. The coefficient of friction between the box and the slope is 0.5. Firstly, find the acceleration of the particle. Secondly, find the distance it slides in the first 4 seconds. So, let's go through and highlight the key points. So we've got the mass, we've got the angle, and we also know the coefficient of friction. Now I can use this information to draw a clear diagram to represent this question. These diagrams need to be quite large and highlight all the forces and in which direction. So firstly, we've got our slope, which we're told is at an angle of 30 degrees. We've next got our box, which has a mass of 5 kilograms. Now, if its mass is 5 kilograms, acting directly downwards, not perpendicular to the slope, it's directly downwards, is 5g, its weight. Now, we also need to highlight in this diagram the normal reaction. Now remember, the normal reaction is always perpendicular to the surface. So its R is there. Now, we're also told that the mu is 0.5. We're also told it's going to slide down the slope. So it's going to slide down that way, which means its friction must be in the opposite direction. And as it's sliding down, we must be looking at the friction max, as if the force pushing it downwards, so it's falling down the slope, if it wasn't big enough, the friction max would stop it from moving. So as it's sliding down, we must assume that the friction max is being used. Right, we're still not finished identifying everything on this question. Because when we look at forces here, we're going to look at it in 2 directions. Remember, we always look at 2 directions perpendicular to each other. Now, the easiest one on an incline question is to look in that direction and to look either up or down the slope, depending on which way the movement is. So we're going to look down the slope in this question. Now, that means that this weight here is not actually being involved in either that direction or in that direction. We need to find out what component of that 5g does act that way and what component acts that way. This involves drawing a triangle here. Now, we know that this triangle here is a right angle triangle, which means 30 add 90 is 120, which means this angle must be 60. Now, as this is perpendicular, this bit here must be 30 if that bit's 60. Now, this is going to be the same for all questions, that you should notice that this angle we've just written down is the same as this angle here. And that will be the same in all of the questions we look at to do with forces on an incline. Now, we can use trigonometry to find out what components of the 5g is acting on this side and what components acting on this side. So, this is the opposite side if we look at this one. So as it's opposite, that means it's going to be sine. So it's 5g sine 30. And this bit here must be 5g cos 30, as we're looking at the adjacent. Because this bit here is the right angle, so that's the hypotenuse, that side here. And that 5g is the hypotenuse of this right angle triangle. Now we've got all the forces we need to know to be able to answer the question above. So firstly, to find the acceleration. Now, the first thing we've got to find, because it's going to be accelerating down the slope, we know that it's not accelerating upwards or downwards, so it's not flying off the surface in this direction. We need to find the acceleration down the slope, which means we need to first find the friction max. Now to do that, that involves finding the forces in this direction. So we're going to find the forces in that direction. Now if we look at our diagram, the things acting in that direction upwards positively are going to be the R, and in the opposite direction negatively it's going to be the 5g cos 30, which is equal to 0. Which means that R is going to be equal to 5g cos 30. Now you don't need to calculate what R is at this stage, you can leave it in that form. Right, now we know what the normal reaction is now, so we can find out what the friction max is, which is equal to mu times R. Now we're told that the mu is 0.5, so it's 0.5 times by 5g cos 30, as that is our normal reaction, which means that our friction max is going to be 2.5 g cos 30. Now we've got our friction max, we can now look to find the forces acting down the slope in this direction. Now remember, acting downwards here is going to be our component of gravity, component of the weight acting down the slope, which is 5g sine 30, and opposing the motion is going to be the friction max, which we've just calculated to be 2.5 g cos 30. So now let's rewrite our equation. Let's write an equation now for the forces acting down the slope. So down the slope is the component of gravity, which is 5g sine 30. Let's just check that on the diagram. So down the slope is 5g sine 30 minus the friction max, because that's opposing the motion, and that's equal to mass times acceleration. So the mass is 5 times the acceleration. We've got this by doing F equals ma. Right, so now we need to just plug it, we need to find out what 5g sine 30 is, what 2.5g cos 30 is, and then divide that answer by 5. So if you do 5g sine 30, you get 24.5. If you do 2.5g cos 30, you get 21.217 ... Don't delete your answer off your calculator. Try to keep your answer as accurate as possible by using the answer button on your calculator. If you take those two away, you get the answer 3.28 ... is equal to 5a. So that means that a is equal to 0.66 ms to the minus 2. That's by doing 3.28 divided by 5. That's how fast this block is accelerating down the slope. Now in part B, we're asked to find the distance it slides in the first 4 seconds. Now, to me, that screams out using SUVAT because we've got a distance and we've got a time. We also know from the question that the box is released, which means we can assume that the box starts off from rest. So the initial velocity speed is 0. So we're now going to use SUVAT to find out part B. So SUVAT, write down the parts we know. So we know the acceleration is 0.66. We know the time is 3. We don't need to know the final velocity. We know it starts off from 0. We're trying to find the distance travelled. Now, we need to find a SUVAT equation that doesn't include V, and that one is the equation S equals UT plus a half AT squared. Now, U is 0, so 0 times anything is 0. So it's a half times 0.66 times 3 squared, which if you figure that out, you get the answer 2.95 metres. So it's really important when looking at questions involving force on an incline, it's really important that you draw yourself a clear diagram. And remember to draw on your diagram what component of the weight is acting down the slope and what component of the weight is acting perpendicular to the slope. And if you can do that, you shouldn't have too many problems with answering questions involving forces on an incline.